So the next session is about smart manufacturing, which aims to automate operations and improve performance. Smart manufacturing can accurately predict the requirements, identify errors, as well as make innovation and the manufacturing process more manageable. In this endeavor, we'll hear from our eminent speakers how to harness the power of data for sustainable future ready enterprise, how India can be future ready for a smart revolution. And with that, now I will hand over this session to Professor Sunil Jha, Director of Smart Manufacturing Center, IIT Delhi. Over to you, sir.
Thank you, Utsav. Very good afternoon to all. Let me share my slides and then I can start. Yeah, so today I will be just sharing my thought process on how to prepare technologists for India's smart manufacturing revolution. And before that, I just want to give you a quick glimpse of what's the vision of we have for the manufacturing excellence. So in fact, you might be knowing some of these facts well, because I would like to show what we are having right now. So we are looking forward for a $1 trillion USD economy coming through the manufacturing sector only. And we are also looking forward for 25% GDP contribution coming from the manufacturing sector by 2025. So these are some of the vision that we have for our country. And we are also looking for the India to become a manufacturing hub for the world. And certainly all ministries are working in this direction. There are initiatives by Department of Heavy Industry to improve the competitiveness of our capital goods sector. We are emphasizing on the technology development. Some of the mother technology can be developed in India. We would like to have a global value chain build up and then skill development as per the global standard. We have already seen a lot of use cases being coming out very nicely during the pandemics. So that's how people get familiar and acquainted with the Industry 4.0. And they have already seen the strength or the capabilities of the remote monitoring, remote access, how the facility become agile and they will help in changing the product so frequently and so on and so forth. Now, the question that we have today is how it is transforming, how we are going to contribute towards the transformation that is happening right now. And then I look forward, I just take you a little back when you have graduated. So we need to see, this is the most important question, how we can make manufacturing as a preferred choice of a career, because we are talking about more technologists contributing towards the manufacturing and the kind of vision that we have for our country. Now, if we see that, because this conference is on world of technology, and we can see that it has no existence without manufacturing. Unless you are able to manufacture something, certainly we will not be able to reap the advantages of the technology. But at the same time, we also understand that not many engineers want to opt for a manufacturing career. So I will just take you a little back the way you started learning the manufacturing and then what exactly we need to transform and what kind of reforms we need to have. So unless we change the perception about manufacturing in early engineering years, because we all get the first familiarity with the manufacturing during our first year of engineering itself, it's very difficult to realize the dreams of a manufacturing economy. So let me just take you a little back where we started our manufacturing understanding journey. So this is the kind of a factory in which an engineer got trained and he get to know about the manufacturing processes from these equipments actually. That's the first interface for all of us, as whether as a student or when I'm teaching this manufacturing to the students from last 15 years. I think this is something we are using right now. And I'm sure that you all are familiar with kind of revolution that has happened over the past. So we are using the technologies of Industry 2.0 right now to train people, to train engineers to get ready for the revolution that we are talking about today. So if you see that the engineer is supposed to work in this environment. So today what we are looking forward, engineer has to work in this kind of factory. And this is what we are talking about, the Industry 4.0. Now, if I will be training students on a technology that is Industry 2.0, and we are expecting them to coming out to work with the technologies that are relevant for Industry 4.0, I think we need to think about it again. So I think with this, because we are looking forward for the manufacturing excellence, we need to do something about this. So that's how we need to redefine the manufacturing learning. That's very important. So if you are trying to excel in the manufacturing, we have to improve the interface for a student, basically how he perceives the manufacturing. And from the first year itself, I think most of the students have not shown much inclination towards the manufacturing activities. That is what my experience. And most of the time we heard about the from the student, that whether it's from computer science and electrical engineering, they said, why we need to learn these subjects which are relevant to mechanical engineering? Why this is compulsory learning for all of us? So now this is a very important questions to be addressed, because when you're talking about the smart manufacturing in the coming years, how everyone from a different discipline can contribute and participate in this revolution. So this is just in a quick glimpse of the kind of technologies that are coming in the domain of manufacturing. So this is just in a survey being done by the PwC about the digital factories 2020, how the technologies are shaping the future of manufacturing. So if you can see, the relevant technologies that are being listed over here are not primarily falling in the domain of mechanical engineering as such. So I'd say that there's a lot of interest to be created with the students from a different disciplines, so that we can see that the way these technologies are going to leapfrog in the next 5 years, it's very significant for all of us. So we are looking forward for the new roles that should be coming out from these new implementations. So we are talking about digital enterprises, digital design, digital manufacturing, digital thread, digital products, and the kind of roles that are coming out, they are being defined basically. So this is one of the report being generated on the design job roles taxonomy, basically in the digital manufacturing and digital design. So there are new roles like digital thread engineer, digital twin architects. We never thought of them earlier, because we are always thinking of a manufacturing job is a core shop floor job where people has to work near the machines in a very different environment, which is full of the dust and heat actually. That is how people are keeping a distance away from the manufacturing. So this is now going to change significantly. And if you see that these are some of the job roles we see in the smart manufacturing domain, and that attracts a lot of youngsters now. And in fact, when we have started this initiative at IIT Delhi, many students have shown inclination to work with us and take out these projects in this digital design and manufacturing. So with this intent, we have this foundation started 3 years back. It's a kind of an industry academia collaboration supported by the Department of Heavy Industry, Government of India. We have created this common engineering facility center under a mission from this ministry on the Samarth Udyog. So they would like to have more smart advanced manufacturing and transformation hubs basically set up in the country. And we were one of that 4 hubs being started in 2017. So current strength we have, basically we have industry partners working with us. So most of the MNCs relevant to, they are working in the different automation sectors. They have joined hands with us in co-creating this facility. It's a very important part, because when we are talking about the smart manufacturing technologies, unless we get to know the state of art, what is there in the state of art, we will not be able to just survive based on the research alone. We also try to bring out various specializations available in the academia, that is the institute, with the help of the different faculty from different discipline, and well supported in terms of the financial contribution or the grant by the ministry. So with this kind of a basic ecosystem, we started this initiative. And the idea is that when we talk about the smart manufacturing technologies like these, the key technologies which need to be deployed today in the factory, we are looking forward. Most of these technologies need to be explored. We need to demystify, basically we need to go through the understanding of these technologies, because as such we don't find many available in the textbooks as such. So we need to do a lot of experimentation with these technologies, and then create a basic infrastructure for learning basically. That is a very important part. Unless the student get exposed to these technologies in the early engineering years, they may not come out with a fascination to do something good in the manufacturing. So with this intent, we created a small factory, which we called initially it's a small lab that we have created. It's in a cyber physical assembly line. This complete setup being created in the IIT Delhi only. We set up an assembly line for an electromechanical valve, which is completely controlled by the cyberspace. So we have an app to trigger the order and execute that order. And then we have also supplement it with a robotic cell. So how a multi-process robotic cell can perform the complete assembly operation within a small footprint actually. So these are some of the examples that we have created in our lab. And idea is that students now get to know about the state of art basically. Now they can do more and more experiments and learning on these technologies. Just in a quick video, I will not be running through in shortage of time, but I will give you a quick glimpse of this cell. Which is there. Is my presentation visible? Yeah. Hello everyone, I am Arun and today I will be explaining this MPRC, that is multi-process robot. So this is the cell that we have created in the lab basically to get the people familiar with the robotics technology, how that will help along with the automation basically to do an assembly operation. So the moment you fire an order to this cell, it will start the complete assembly operation. So we have just shown the different interplay of the technologies inside the cell. The robotics, automation, the packaging, the different tool changers, different smart sensors, how they have been used, different actuators, how they have been put together to do this assembly operations. So this is one of the state-of-art facility that we have created over here. So I just want to run through the quick demonstration of this. Once this order is being picked up or fired by the user, the assembly operations start with the help of the robot at the different stations. Finally, the product gets functionally tested. That's a very important part. This cell will also test the product functionally. And finally, the product gets packaged and then will be delivered. So that's a very important part of this. And we will be able to do the complete programming of this robot along with the automation technologies. So that's another important aspect, how we will be addressing the need of learning. Because if you are supposed to deal with the multiple hardware, am I going to learn all the hardware and the interfaces and the programming? So this is one of the example where we try to control the motion of the robot with the help of the PLCs, that's the programmable logic controllers. So that way, I think it will reduce the programming and the changing of the programming task very significantly with this. So this is just a one demonstration that I had from the lab for you. The next initiative that we have taken is basically to modernize our own and the central workshop. So the kind of a factory that I was showing you where you're supposed to learn these technologies now need to be changed actually. So we have decided to do some transformation in our own central workshop so that we will be having a connectivity with the various machines, which are the CNC machines or or we will be having a conventional machines as well. We would like to connect them with an autonomous mobile robot, with a collaborative robot for the different material handling requirements. At the same time, we'll also would like to add the state-of-art, the robotic welding cell. So some of the new additions basically to get the students familiar with these new developments. We are also working towards the integration of this smart factory with the 5G. So this is an initiative going on, and we are also looking forward to integrate the 5G communication and bring out more relevant use cases, means how this the high speed, the low latency and high reliable communication will transform the communication in the factory. The another important aspect when we comes to this deployment of these solutions to the MSME, it's very important what kind of application framework we can have. So we are working in that direction also. We are creating some of the application framework that can be directly deployed for certain implementation in the factory that for the MSME. So this is one of the application which keep on monitoring the machines, the production, and it can also communicate with the operator and the maintenance people. The another facility that we have created now is basically the robotic welding cell. So this is another concept where we would like to offer the manufacturing facility as a service actually, because most of the time when we realize that we are not running them at a 100% OE or it's not utilized because it's being specialized for making certain product, we are looking forward such a flexible cell where we will be able to offer it as a service. So it's a kind of a resource that is available for anyone to utilize. So we just look forward to transform this welding cell with the help of 2 robots to deliver it as a service, where anyone can upload his customized order, and then this cell will keep track of the different data that is relevant for doing that particular welding operation. It will also be having a system for automatic identification as well as the inspection part of this. So we have designed this complete architecture over here. Now this kind of an exposure is very important for the technologists who would like to work in the domain of the smart manufacturing. It will not be coming out from just one discipline learning, and that is what the industry is looking forward. So we would like to generate more interest to the students that how they can contribute towards this integration. So how to design the architecture, how the IIoT can be implemented, how the programming for the multiple robots can be handled in this case, and how a master PLC can control the operations in this scenario. So we have designed this architecture where the customer can upload the required data files to the system, and there would be a local production server which will be controlling the functionality of the cell. And cell will be dealing with the 2 robots. So there will be 2 robot controllers, and then there will be a master PLC which will be coordinating the motion between the 2 robot controllers. And we are also looking forward, before the part is being delivered, it should also have an arrangement to do the welding inspection. So this is the welding cell in creation right now. So my colleague Rajesh will quickly explain that.
Good evening, everyone. My name is Rajesh Bhatt, and we are here at Central Workshop in Welding Shop. And today I'm here to introduce you to the Robotic Welding Cell project. So, this project is actually a smart manufacturing project in which we have demonstrated a flexible manufacturing cell, meaning right now.
So idea is that basically how the students get familiarity with the same technology which is going to be used after the 4 years of the graduation. So many times it comes to the surprise when they land up in the shop floor and they see that, yeah, we have learned the welding by hand only. We don't have any exposure how the robot can be controlled, how they can be utilized to do the welding operation. So there are many manufacturing challenges that can be addressed if we get the students get familiarity with these technologies in the early years itself. So this is one of the cell that we are right now creating. Most important part is how the different technologies put to interact with each other. So it's in a welding power source, how the parameters being controlled by the cyber controls that we can have, and how these two robots can be put together to do the coordinated operations for performing any welding operations. So that's an important part over here, and I would just like to quickly show you. So once the user upload the program, and then we will also be having an intermediate storage within the cell only. So the moment the scheduling happens for that particular part, robot will go and just do the welding operation. So that is how we are looking forward this cell. So students can learn how to program the coordination between the two robots, how a particular weld program can be created, and certainly that will be then delivered to this cell for the manufacturing. Then I would also like to give you a quick glimpse basically of a training system that's very important, because the state-of-art hardware that we are talking about, when we normally encounter when we go to the factory once we join some job which is on the manufacturing automation or for the maintenance for the manufacturing equipments, we never come across this state-of-art hardware because we never did a lab truly on this hardware, how to program them, how to interface the smart sensors, how the technology will interplay between the different communication protocols. To give them a quick glimpse of these technologies, we have created this smart manufacturing training lab at IIT Delhi. So we have the variety of hardware being available over here to experiment with. This training kit that is being designed, keeping in mind that the student will be able to do all sort of experiments. And this facility not only available for the students, even people from industry can come and work on these training kits. They can take out some kind of a prototyping of their ideas. And for example, if you talk about the IIoT implementation, so how the different hardware can communicate on the different protocols, how the data will go to the server, all these kind of experiments can be done with this basic infrastructure that we have created in this foundation. We have also added an electromechanical hardware kit also, because one side we have controllers communicating with the machines, and we also have motions being performed by the motors, then the various sensors capturing the data, and then the vision is also being utilized to process the quality data. So giving all the complete exposure through this. And the more important point is that we have utilized this facility in the last 1.5 years just to train people remotely, because this complete hardware is accessible remotely to train a lot of people around it. And we would like to run this facility 24/7. So if you just book your slot to do an experiment on this facility, you will be allowed to do that. So this is just a quick glimpse of the inside of the lab only. So I will be just giving you a quick glimpse. So two of my colleagues will be giving you a quick idea on that. So I'm not going to run through the complete video, but they are explaining basically the different hardware that is there into the lab, and the different controllers, different interfaces for the sensors, and how we can connect them together with the electromechanical system to control the functionality of a motion, as well as how the data from a vision sensor can be processed basically. So these are the different functionalities. So we have designed a part over here which can be placed onto this electromechanical platform, and the operation can be triggered. So this is representing almost like a machine which will be processing certain parts over here. The experiments can be done by interfacing with these controllers, and then the different environment can be exploited for this learning. So that's the learning environment that has been created. Another aspect, sometimes we don't have only the physical access to this hardware always. So if you would like to take this learning to a mass, the another aspect that we have attempted is the AR training kits. So augmented reality training kits has been, so this is another application that has been built by us. People can utilize their mobile devices, tablets basically, to visualize the same hardware. So whatever hardware we have shown physically in the lab, that can be visualized in front of their mobile devices, and they will be able to experience the functionality through this augmented view of the same training environment. So they can connect with the system, they can write their own program, and they can see the results in the simulated environment on this AR, the AR application. And we will also be able to monitor the experiments done on this AR environments. It's very important for tracking the users, basically, whether they are performing the right learning or not. So this is another dimension to the learning that we have planned. So if you look at this kind of the exposure to the technology, and this kind of technology themselves will be used to train the people, I think that is something is very much required when we are looking forward for the technologists or the engineers to contribute towards the manufacturing. This is another demonstration that we have created in the lab, basically how to visualize the different motions of a collaborative robot with the help of AR. So,
hello everyone, my name is Vaibhav Anand, and I work on AR applications, that is augmented reality applications, and I will demonstrate this application that we have created. So this is to learn about cobots and how to visualize the joints of cobots. So for this we need a QR code. So first I will log in the application. So as I have logged in the application, I have a menu and I click on working of cobot. So once the menu appears, it will just start the camera, and I need a QR code. So Arun, can you please pass me the QR code?
Yes, sir.
Thank you. So now we have the QR code, and as I will move the camera toward the QR code, the cobot will appear. So as you can see, the cobot is here, and I have multiple sliders here which I can use to do different functions. For example, I have the scaling slider which can be used to scale the cobot up and down. I can also use the joints which are displayed here, so I can move the joints to move the cobot as I require. So this is a very good way to visualize the cobot without having any physical access to the cobot in this time. So
idea is this, basically once we have this interface built at the AR again, we will be able to control the motion of this cobot also through the programming interface. So this is just a slider which has been shown in this AR, but we would like to control this complete collaborative robot with the help of the programming environment, which is going to control in the real environment. Also at the same time, we can perform all the simulation of the pick and place functionality by this collaborative robot and identify the space in which it's supposed to operate with the help of AR only before you physically deploy this robot. So these are some of the advantages, and it gives quite an immersive experience to the students to work around these technologies. We have also built some of the use cases for the real maintenance in our own machines using the same technology. So many times it's very difficult to trace out the real problem and then to give a guidance basically to the maintenance engineer how the maintenance can be done. So on this equipment, if you can see that we have developed this application where you can scan the identification of a machine, and from there I will be able to retrieve the digital information about this machine. So and through IoT I can come to know about the status of the various sensors. The data can be superimposed onto the machine itself, and we realize that if the temperature of a motor is not within the acceptable range, it will present you the troubleshooting guide. So that way the person or the maintenance engineer will be interacting live with the whole system, and he will be getting the instructions in front of him only. And when he decides to replace a particular motor on this equipment, so the complete sequence can be made to run through. Many times the instructions that are being given in the labs are not sufficient enough, so a student can utilize the similar technology and interfaces to explore the systems further actually. So this is another dimension, and we will also be using the same applications on the shop floor. So industry can do a lot of experiment with these technologies, how they can be able to reduce the maintenance time. So first of all, to identify the problem that can be attempted with the help of the analysis of the IoT data stream. And post that, once you identify the problem is in a particular component, and then you can guide an operator or the maintenance engineer to perform that operations, and you will capture the data also who did this maintenance activity. So these all technologies are basically at the forefront of the industry 4.0 implementation, and in this facility our intent is to basically give the same exposure to the people from industry as well as the students to learn on. The another interface that we have worked right now is basically now deploying this autonomous mobile robot in our workshop only, because I would like to bring out the same environment which is going to be used in the industry we are talking about. In this case, we are attempting the coordination of the communication between the two robots over here. One is the autonomous mobile robot. Another is on the collaborative robot that is placed on top of that. So how you can do the material handling within the different shops of the workshop. So material can be inspected with the onboard camera on this collaborative robot, and then the material being transported for the another location. So this is the application where it can do the pick and place. The important part is that the two industrial controllers are now being interfaced with the open source robot operating system, and how we will be utilizing the ROS to communicate between the two different industrial controllers, because through that it will imbibe a lot of learning and we will have a more flexibility to control the different operations. So these are the functionalities that are being developed. So it's a kind of a research that we are doing on these areas, but at the same time it will also be exposing the students and the people from industry to understand how this technology can operate. So this is just in a programming again done by the people in the lab only. So they will be controlling this collaborative robot completely from the ROS environment. So they will be setting up the goal from where the robot to move to what the final destination, and the complete path planning is being done by the ROS library only. So we are using the move it here. So the motion that you can see here is the physical is also being done in the simulation. So the advantage of ROS is that we need not to change the programming for the simulation and for the physical system control. It's the same environment, and you can check in the simulation and it can also be deployed. The another development that we are doing is basically to transform the lathe. That's one of the equipment that most of you deal with when you do the workshop. So how we can make it in a smart so that we can produce the right product quality, we can monitor the machine health, and we can also give some guidance to the operator. Many times when you do the job, you will end up in getting in a very poor surface finish. So that's how you can control those parameters. So this is one of the deployment that has been done in the workshop. So my colleague is explaining that. So we have integrated the sensors and the controller with this lathe, which is in a conventional old machine. We would like to monitor the different parameters so that we can guide an operator to do the right cutting conditions can be maintained. So it will be guiding if you are not maintaining a right depth of cut, or if you are not maintaining a right feed rate, it will guide you. It will indicate that you are going beyond the read. So then you will be able to change those conditions to give a good output over here. And at the same time, we'll also be monitoring the energy consumption over here. We have also implemented some of the safety measures basically in this smart lathe machine. And if you are not meeting certain interlocks, you will not be able to run this chuck. So that's a very important part of the safety. We have also created this kind of an IoT interface for this lathe machine itself, which is very useful for the smart factory implementation. So once the student get familiarity with this, we would like to give them an exposure, means how this technology can help us in improving the productivity, producing the right part with the right quality, and how we can monitor basically the different maintenance parameters. So I think that's a very good exposure that can be built on top of that. So in this short span, I just give you a quick glimpse basically how the basic technology learning can happen with this kind of an implementation that can be taken up. So idea is that we have an action plan that we would like to modernize the basic manufacturing learning. That's a very important way, because when we have a lot of expectation from the manufacturing, we are looking forward for this manufacturing hub. India should be a manufacturing hub and in the world. We have to improve upon this basic manufacturing learning, and it all starts with the basic infrastructure. We have to update the manufacturing curricula. Certainly the basics are very important to learn, but we also need to get acquainted with the state of art, what is being deployed in the world actually. So how it is going to help our own industry to become more competitive in this case. And finally, we should bring out more open problems to our young minds to solve these manufacturing issues. So they are very innovative, because now a computer science guy can also find a connect with this manufacturing, because he can now apply the machine learning algorithms for doing the predictive maintenance. There's a computer vision problem to be addressed. There are multiple sensors and the controllers being involved in the manufacturing. So now it will bring out a lot of interest to all people who are supposed to learn the manufacturing now, and they can opt for a manufacturing career with this development. So that's all from my side. Thanks. We are looking forward for all your support to strengthen this development that we are doing right now, so that we can bring out more technologists to support this industrial revolution for India. Thank you so much.
Thank you, Sunil sir. It was a really compelling session, and it helped us get so much of details of the smart manufacturing. And with that, I will now move on to the next speaker, Mr. Dilip Sahani, the MD of Rockwell Automation India. Over to you, sir.
Thank you so much, Utsav. And Dr. Jha, that was a very engaging session. And particularly, you almost practically took us there, and really enjoyed those conversations. Before I get started, let me just quickly try and share my screen. Well, it's first of all, my pleasure and a distinct honor to be speaking with such a wide audience and such a critical sort of part of our talent pool across various generations. So thank you so much for offering the opportunity to me. What I thought I could do today is engage with you and walk you through a little bit, from coming from an industrial smart manufacturing point of view, the impact of data and how the power of data science is enabling us to reimagine manufacturing altogether. In many ways, it's going to be building up on what Dr. Jha has already taken us through. Before I get started, I'll probably spend half a minute to share a little bit about my own background, where I'm coming from. I work for Rockwell Automation. Rockwell Automation is a global leader in industrial automation and information. Our mission is to bring the connected enterprise to life. We're helping industrial companies and their employees to become more productive. Today, I'll be using, a lot of our knowledge and expertise from our Calypso business. And Calypso is basically our digital practice. Through Calypso, Rockwell Automation actually delivers digital transformations to a wide array of customers across the globe. And there's a lot of expertise all the way from consulting, data science, technology, and of course, managed services across a varied set of industries, which are as diverse as life sciences, consumer, industrial, high-tech, that covers a vast majority of industries like metal mining, cement, oil and gas, et cetera, et cetera, et cetera. So without any further ado, let me just dive in today into what's going on in the world around us, particularly in the context of manufacturing. There's a whole lot going on, and as if that transformation was not enough, we've seen in the last 18 months or thereabouts, another one step change in the need for transformation, which was triggered by the pandemic and our response to the pandemic, right? So there are a couple of things that are going on. One is the conventional expectations out of manufacturers, they all stay there. The need to continue to become more productive, the need to become more efficient in terms of resource utilization, reduce quality defects, et cetera, all of those factors stay there. They're there, and they are expectations. Each year we have to push the envelope and continue doing things in a better way. But the market trends, the trends in the marketplace are changing very, very rapidly, driven by consumer demands. Consumers like us, we are becoming very, very demanding. The manner in which we are consuming, the manner in which our demands are being fulfilled, without even stepping out of our homes, we can get the entire world on a click, right? Choice-wise, that is. And that's placing an enormous amount of burden on manufacturers, all the way from car makers to people who are making yogurts, or people who may be making drugs and pills, etc. This is having a direct impact on them. At the same time, there is an enormous amount of impact that's happened because of supply chain and labor-related discontinuities, that we witnessed in the last 12, 18 months. Some of these trends are going to linger. Some of these trends, boards and business leaders are demanding their organizations to demonstrate their resilience, right? At the same time, the sustainability related expectations have gone from here to here, meaning we are witnessing the impact of climate change, and businesses are being challenged to demonstrate their commitment to make a positive impact in that direction. So it's all of the conventional responses of manufacturers are going to be falling very short in terms of creating a response and demonstrating global level competitiveness for manufacturing businesses, particularly in the context of India, unless and until we completely reimagine manufacturing, which is where Industry 4.0 and technology enabled innovation is playing a very big role. I think this whole idea, the notion of digital transformation, is affording to manufacturers a degree of freedom that was previously not available, right? It's opening up possibilities that we did not even consider to be choices, but now they are not just choices, but they are very real. And all of it is being enabled by these digital technologies, the foundation of which is data. And that's going to be one part of, that's going to be the aspect that I'm going to be exploring with you all today. So just moving on, if what we are talking about is data, all of us have been hearing about data being the new oil, or whichever simile or whichever parallel the version of it that you've heard about. I want to just spend a minute before I get started to explore this with you. Of course, data is very important. Of course, fact-based decision-making is something that we've been practicing in organizations for decades and decades. That's the reason you have hierarchies of management, and they all believe that they're acting on precise information and insights that are coming, from various parts of their business and enterprise. But if you really analyze, even in organizations that have enterprise-wide business systems, today, even in those many of those organizations, what really happens is business leaders at multiple levels, who are making decisions. You're making decisions not only because you're a CEO, you're making decisions while you're a supervisor in a plant, or you're a line side operator. Each one of them is making decisions. But the graphic on the left-hand side on the screens in front of you actually captures what is commonly the as-is state, where decisions are being made in the organizations on the basis of historical data in a very hierarchically organized manner, right? You have shift reports, and you have monthly reports, and you have management information reports, which are all communicated digitally in very compelling visual manner, right? But essentially, they're based off of information which, when it is produced, begins to become stale, right? The as-is scenario, which is becoming very important, particularly in these times when the decision-making time windows are shrinking, is the scenario that's on the right-hand side, which is where organizations are transitioning to making decisions on transparent, real-time data. That's the data thread that connects the entire organization together. And if there's a change, that change appropriately in an appropriate manner to respective consumers across the organization gets relayed. The entire organization in that scenario gets connected through one version of truth, right? And you can actually rewire yourself in response to stimuli that are coming from the external world or the internal realities as it might happen. For example, if a portion of your plant suddenly goes down, how do you readjust those things? And what impacts does it have, downstream in your organization, et cetera, right? An instance of transparent live data allows you to achieve those things. Those organizations are more agile, and they hence are much more competitive. They are even more competitive in a scenario where you begin to assume that the time constants are shrinking and shrinking very rapidly. So I'll just leave it at that. I wanted to talk about the, imagining data and data in its right context, right, being a key differentiator and a competitive advantage. So I'll leave it at that. and I'll move on. So today I'm going to be, Dr. Jha spoke about, a set of use cases which are very common. I'm going to explore another end of the industry, which is more process oriented, just to throw in some diversity for this audience, right? Now, what does digital mean to industry, particularly industries like process heavy industries at large, right? I think it's very important for us to demystify and take the jargon out, right? And there are going to be a few of these aspects that I'll try and explore with you in the available time today. I think I'd like to begin by first of all stating that the world that we live in, that world is an analog world, right? All of the things that happen around us, they are analog things. That's how even processes and plants function. That's how machines function. It's analog, right? Our own perception of the world also is very analog, right? It's not that you say, yeah, I mean, a light is on or light is off is digital, but you know what I'm saying, right? It's not that you see something in an on-off state, but at the same time, when you try and bring in the impact of digital technologies, which I'll be diving deeper into, digital offers a very new way for us to visualize and analyze the world, opening up several new lenses and new vistas, which enriches your experience and actually augments your capabilities to make better decisions faster, right? And that's what is at the core of this, right? So I would say that even if the world around us is analog, but we are now living in the digital analog world simultaneously. And that is heightening our experience, and that is also amplifying our capabilities to make a much bigger impact as individuals and as organizations, right? So when we talk about industry, and if you look at plants, any organization, for the organization to begin to operate at a higher level, you cannot just imagine that we'll infuse new technology and suddenly the operating capacity or the overall organizational impact increases. The reason for that is you not only have to improve technology, but at the same time, you got to be improving processes, and you also have to create an impact on your workforce, which is of an even scale, right? So it's technology, processes, and people, and then you have to really have a end-to-end view of your organization, all the way from design to where you manufacture inside your plant, and of course taking into account the workflow elements, right? And when you reimagine your all three aspects of this under the people, processes, and technology dimensions in the digital realm, and if you're able to actually imagine a future state, that's when you're able to really create a game-changing impact in your business. And those are some of the things that we'll talk about today. So when we talk about digital transformation, there's this notion of digital thread. A digital thread, exactly what it is. Digital thread basically is a seamless flow of data, as you see over here, that connects the business processes across your value chain, right? And you can break it up into 4 phases or 4 parts, which is discover, create, make, and sell. Now, no matter which industry you belong to, that's usually the life cycle. That's how you begin to add value. It could be a discrete industry, it could be a process-heavy industry, it could be chemical, right? You discover, which is could be a rough, surrogate for R&D or whatever else, and then you actually create. You may be creating it in the digital realm, right? And then you make, that's manufacturing, and then you eventually sell, and that's your supply chain, et cetera, right? Now, if you have a common seamless flow of data that interconnects all 4 parts of this, that's your entire enterprise, that's the digital thread, right? And that enables you to have the kind of impact that we've been talking about. And some of these things that I've noted here at the bottom of the screen here for you, right? Capture the impact that you would be able to create. Digital integration, across the silos that we've seen, right? What have operated as as islands or silos within the organization can actually be effectively connected. And you can unlock a lot of value because you'll be able to connect it in a seamless manner. And when I was talking about the instance of live transparent data, you can very easily imagine that by creating this digital thread, right? Now, if that is the digital thread, right, digital affords you to do many things which are not possible in the physical realm, or at least are extremely hard and difficult to realize in the physical realm, right? And digital twin is one such example. What I mean by a digital twin essentially is digital twin is, as I've noted over here, it's a superior representation of a physical entity or a system, right? Essentially, what you do is by taking, in the context of industry or manufacturing, taking the engineering designs and blending that with the live streaming real data, you're able to literally simulate or emulate the entity or the model. And there are 5 different kinds of examples that are noted over here at the bottom of the screen, right? But you're able to literally realize that in the virtual realm. Now, you may ask, what value do you get out of that? Enormous. The value is that you can carry out simulations in the virtual realm, which would be very, very hard or sometimes outrightly dangerous to do on a running plant, right? You may have tens of digital twins or 100 digital twins across your digital thread, right? But each one of them literally is a replica of a physical entity or a process, right? That is there in the physical plant. And you may imagine that there is imagine a bioreactor, and you have digital twin of a bioreactor, which is doing everything. If it's a high fidelity representation or replication of the real thing, we've been able to achieve that. And in many instances, we are getting there where we are very close to the real thing. If you're able to build that high fidelity digital twin, you can easily almost predict the response of the system to a stimulus, to changes, right? And when you're able to do that, you can analyze whether the response that you're getting from the system is acceptable to you or not. And if it is, then by all means, go ahead and carry out that change, right? And you make that change as the operator or as a supervisor who may be authorizing it. You do that with full confidence. So it is enabling you to make better decisions faster. That was the comment I was making earlier. Another manifestation of that in the real world is in continuous industries, what used to, or in chemical industries as such, what used to previously happen, or take the example of life sciences, pharmaceuticals, you would have, the design teams working on bench scale, experimentation that they'll prove, and then it'll go on to a pilot plant. And then if the pilot is giving, good results, then you would actually take it for full-scale commercialization or manufacturing, right? If you have a high-fidelity digital twin, you could actually straight away skip that stage of piloting, and people are doing that. So that is faster time to market, right? You're saving sometimes a few years to get to commercialization. So that is competitive advantage, right? And that's happening because you're blending in these digital technologies into conventional industries which are decades old. So, I can go on a few more examples, different end of the spectrum, utilizing 3D data to simulate or to project onto real life equipments, digital information that augments the capacity of operators. Again, it allows them to make decisions in a much more, with a lot greater confidence, and again, making better decisions faster, right? So I could probably spend some more time in case you have questions, exploring this aspect further. But I do want to quickly talk about, the realization of IoT in the industrial sense. Everyone has heard about IoT. We all actually are experiencing it in our daily lives with their, wearables and whatever things we have in our homes increasingly. But the industrial Internet of Things is a real deal. And it is game changing. It's creating a huge impact because sensorization is allowing you to get information out of your processes which you previously did not have. And this information, which is seamlessly flowing in, streaming in practically in real time, it's not that information was not available. Instrumentation has been used by industry for decades. But the manner in which the cost of sensors and the ease with which IoT is integrating a vast majority of things which are not just industrial instruments, but a vast majority of other things that are listed down over there, that's creating an enormous advantage, because contextualized data of this nature allows you to create superior models. So that allows you to create better digital twins and have that digital thread easily realized, right? And before I wrap this up, I thought it is very, very important to also, in the industrial context, bring out this dimension of people, right? You have to have a human-centered approach that recognizes that there is human behavior that is involved. So there is a change that is happening, and that change is, unless and until business leaders and everyone in their individual capacities commit themselves to that change, that can actually undermine the efforts of this transformation that we are trying to cause, to go to a data-backed, a fact-based, world. It's a cultural shift, and to be able to achieve that without too many surprises, one needs to recognize that we have to factor in the human element again. So in the interest of time, I'll wrap it up over here, but before the segment is over, I'll be happy to take any questions. Thank you so much. And back to you, Utsav.
Thank you so much, sir. It was a really refreshing perspective, and the last two talks, as Professor Jha and your talk, we understood the diverse topics and how they're related and how they're adding value to the whole value chain. And with that, we're going to the last and the third speaker, the last speaker of this segment, Smart Manufacturing, Mr. Jonas Burge, and he's the Senior Director of Emerson Automation Solutions. So without much ado, I'll hand it over to Jonas. Over to you.
Thank you. Imagine a green plant, a sustainable plant with no undetected leaks, no unaccounted emissions, no undetected passing, no hidden fouling causing inefficiency, and no undetected overconsumption. That is really the vision of sustainability and digital transformation in plants. Okay? So today I'll speak about three things. First, why plants are changing, because they want to become greener and more sustainable. Then I'm going to talk about how plants are changing through new work processes driven by automatically detecting inefficiency, losses, leaks, and overconsumption. And lastly, I'm going to talk about what plants are changing. They are adding automation, really towards hyper-automation, including sensors and artificial intelligence analytics. Okay, so I'm really going to talk about the why, the how, and the what. Okay, but I'm going to start with why plants are changing. Well, they want to become more green, they meet their ESG and CSR commitments, which includes sustainability. Okay, yet plant equipment foul, it fails, it has suboptimal or incorrect settings, and so on. And this causes inefficiency, overconsumption, losses, flaring, and other CO2 emissions. Okay, so this is why plants want to change. So how do plants change? Well, Industry 4.0 or Fourth Industrial Revolution, digital transformation, digitalization, or industrial Internet of Things, or IIoT, whatever you prefer to call it, okay? That includes work practices that helps multiple domains, for improved reliability, greater sustainability, it makes the plant a safer place to work, and reduces off-spec product, okay? But today the focus is on the sustainability part of it, okay? And that's really enabled by automatic detection of inefficiency, losses, leaks, and overconsumption, and so on. Okay, and that enables plants to quickly fix it and restore plant performance, to reduce their energy consumption and thereby being sustainable. So what do plants need to do to achieve this? Well, they need to add in more automation. So until now, plants really been driven very much based on reports, with KPIs. Reports and KPIs tend to be lagging, end of the day, end of the week, and that sort of thing. But become more proactive, respond, and therefore they need to have real-time dashboards with real-time indexes that tells them what's going on in the plant. Okay, and they get that on real-time dashboards. Okay, and which are personalized. Okay, so for instance, if you are involved in sustainability, then you would have oxygen or whatever utilities that you are using in your process. Okay, and all of this information in the dashboard, it comes from underlying analytics, so it could be from energy management information systems, performance monitoring analytics, condition monitoring analytics, and emissions monitoring analytics, for instance. So manual energy management is very time consuming, and it's also lagging, as in, manually reading, flow meters, etc. Okay, and metering at plant battery limits or at the source, like as these utilities cross into the plant or coming out of the boiler or compressor. Okay, that is insufficient. Okay, you need in-depth data and analysis of how energy flows throughout the plant. Okay, because this enables cost accounting, which drives consumption accountability. It allows you to detect and pinpoint overconsumption, to restore plant performance. It gives you automatic reports and dashboards, that automatically, right? So now you become more productive, but also more responsive and proactive. And it allows, mass balance and energy balance, so you can pinpoint leaks, and which drives repair. So that's really how plants have now become more sustainable. Yeah. So they are tracking these utilities from it comes in across the to the plant or out of the production, and as it goes into the various plant areas and units and so on. And this is done through an energy management information system or EMIS. And an EMIS system, it has a software portion and a hardware portion. And everything is really built on top of the hardware platform, which is mostly like flow meters and electricity meters, right? What the software portion does, this is what you see right here. Okay, it provides that granular consumption tracking. Okay, so you see what is the consumption not only for the plant as a whole, but in individual units or areas and individual units, and even down to individual pieces of equipment. Maybe not all, but at least all of the major consumers. Okay, so now you can see where energy is going. Okay, and there is energy account centers accordingly, and so this drives more responsible use of energy in the plant. Yeah. And the EMIS also provides, detailed consumption reports. So you don't have to manually gather all of the data. It's generated automatically, and also automatically generated performance dashboards. So you can see up to the minute what's happening in the plant. Perhaps most interesting, is that the EMIS also provide, dynamically computes energy targets based on the production rate. Okay, so and that's done using an internal model. Okay, so let's say you're a refinery and right now you're running at 250,000 barrels per day. Let's say that's your production rate. Well, based on that, the model then calculates what should be the consumption of water, air, gas, electricity, and steam and other utilities. Okay, and and then it compares that against the actual measured consumption. Okay, so if you have overconsumption now, then that triggers that alarm, and it kind of pinpoints where in the plant this is happening and which utility it is happening to. Okay, so now you can dispatch basically a troubleshooting team to fix that. Why is it over consuming that particular utility at that particular place, and do something about it. The software then also provides that root cause analysis. Okay, so it tells you, is it fouling of heat transfer surfaces, or is it inefficient combustion? Is something broken, or is there something running that really should have been turned off? And lastly, also granular energy and mass balancing. Okay, so if there's a leak somewhere in the system, maybe in a piping system underground, you can kind of more closely pinpoint where this is occurring. Now, so this model used in the EMIS to compute the target, well, that's a good example of artificial intelligence. Okay, so in the case of well-known unit processes, it's using models, which are based on first principles, because many unit processes are already well understood, and the first principles behind them are well documented. So that just goes straight into the AI model. Okay, but there might also be not so well-known processes in the plant, right? And in that case, then you can use machine learning to extract knowledge from process data. So, and you can do that using, regression analysis or principal component analysis. Okay, so now you extract that knowledge, those correlations, and you build a model based on that. But you need a lot of data to do this. Okay, and then these models are then used for the targeting. Well, all of these EMIS functions I've been talking about really are built on top of sub-metering. Because metering only at the plant battery limits, or as steam comes out of the boiler or out of the compressor, that is not sufficient. Okay, you need sub-metering, at area, unit, and equipment level. Yeah. And because the sub-metering really determines the precision and granularity of the EMIS functions, like the accuracy of the cost and accounting, the precision with which overconsumption is pinpointed to a particular part of the plant, the accuracy of the reporting and dashboards, and precision again of how leaks are pinpointed to a particular place within the plant. Okay, so sub-metering is very important. So there's some confusion sometimes about the terminology used around all of this. So like sometimes artificial intelligence, machine learning, and neural networks might be used interchangeably, but they're not exactly the same. Okay, so artificial intelligence is kind of the broader term, and under artificial intelligence there are two branches, like engineered analytics and data science. Okay, so by engineered analytics, I mean, for example, pre-programmed, rule-based analytics. Okay, and that may include, for instance, using cause and effect, which is really the best way to do condition monitoring of equipment like pumps and compressors and turbines, etc. And it includes, first principles, such as thermodynamics, which is really the best way of doing performance monitoring of, heat exchangers and cooling towers and so on. Okay, so in fact, a majority of use cases in a plant really are using such engineered analytics. Okay, but there is also use of data science, of course. So data science again has two branches. There's like machine learning and there's deep learning. So machine learning, well, that includes regression, principal component analysis, support vector machine, artificial neural networks, etc. And that's really best used when the cause and effect or the first principles of something is not well known. Okay, for example, in the case of human behavior, humans are very complex, right? So, and there's no first principles. So that's whenever we look at analyzing human behavior, we go down the route of statistics and data science. Okay, but very complex composites, of many types of equipment and many pieces of equipment and many unit processes can also have complex interacting behavior. So in this case, again, machine learning comes into play. Lastly, yeah, deep learning, that is more like for audio and video type of analytics. Okay, so analytics is a toolbox, right? The hammer is not the right tool for everything. Similarly, in analytics, you need to use the right tool for the job. It could be a hammer, it could be a spanner, it could be a screwdriver. Okay, you get the analogy. Anyway, so today, a lot of things in the plant is still done manually. It's only the core process control, which is really automatic, you know. For example, to monitor steam traps, that's very manual through manual surveys, usually done yearly, okay? And since it's yearly, that means a steam trap can be blowing steam for 6 months to a year, costing you lots of money in loss of steam and, you know, increasing your carbon footprint. So now, and also another way it can fail is trapping condensate, right? And that causes inefficiency, and it can also lead to a whole host of other problems, okay? So either way, this needs to be detected fast, okay? So what plants are doing is that they're putting in sensors like the one you see on top right. You know, so it sends acoustic noise and temperature data to the analytics that then tells you the health of the steam trap, you know, and it tells you if it's failed blowing steam or trapping condensate. So it's a descriptive analytics, not just telling you it failed or anomaly or something like that. So now you know that you need to replace the steam trap. You know, so it's prescriptive analytics. And all of this analytics is ready-made. It's tested and proven in many other sites. You don't have to do any coding. You don't have to do the testing or pilots. It's ready to be deployed. And this is not general purpose analytics. It's purpose built for this job, you know, with lots of built-in subject matter expertise, you know, that allows this analytics to do a really good job with all kinds of subjects. Yeah? Similarly, relief valves are manually inspected today, okay? And again, maybe yearly, okay? So plants put in automation for this, the sensor and the analytics. You know, sensor is not enough, analytics is not enough. You need both. Okay. So now, if the steam trap is, the relief valve is releasing, you get a precise timestamp of that, and you can correlate it to process events and make changes to prevent releases in the future. Okay. Worst case, if the relief valve is stuck open, yeah, you get to see that too. But even if the relief valve is actually it's not releasing, but it has seeped back after a release, and it's not shutting tightly. There's a small leak, but that small leak at the seat over time, weeks, months, years, cause great losses. Okay, so you are able to detect this as well. So now you can send that relief valve for overhaul to stop product losses. Yeah. Efficiency, okay, so fouling reduces equipment efficiency, okay, and which increases power consumption because the equipment needs to work harder, okay. So of course you can clean the equipment, but cleaning, that means downtime and lost production, so that's also not good. So really what you got to do, you got to optimize the time when you clean the equipment. Now, manual monitoring to figure this out, well, it's time consuming, it's lagging, generally difficult to do, so not an effective solution. So again, plants are now automating this. So they put in the additional sensors and the software, okay? So with that, you can actually, through the software, you can tell what is the fouling happening inside, let's say, the heat exchanger, because you have the fouling factor there. So based on that, you know that, oh, do I need to clean the heat exchanger today, or can I wait until the next turnaround, or should I do it maybe sometime in between when convenient, right? And if the heat exchanger has multiple bundles, so a bank of multiple bundles, it pinpoints to which bundle you need to clean, okay? So you can actually bypass then just that bundle, clean that bundle, rather than having to clean the entire heat exchanger, okay? So a good solution. Similarly for cooling towers, additional sensors, and that now helps you optimize based on the efficiency, tells you when to do the cleaning, so because there's, if there's of the filler, or if you need to replace the filler, and also allows you to optimize the chemical, anti-fouling chemical injection, okay? All to stay as sustainable as possible. And lastly, another example, air-cooled heat exchanger, I think you get it, additional sensors and the software. hardware. And if you have an air-cooled heat exchanger or fin fan, to call it, with multiple cells, it tells you pinpoint which cell is fouling and needs cleaning up, right? Well, so the focus today is really on sustainability, but I cannot not mention a few words about the decarbonization megatrend, which we are embarking on, okay? Because now we're building a lot of new plants for this new hydrogen economy, okay? And if you look across the hydrogen and ammonia value chains, there are lots of plants, okay? And they are relatively small. And by that, I mean, okay, if you look at a coal-fired thermal power plant, right, those can be hundreds of megawatts, 1,000 megawatts or more, okay? Whereas if you look at these hydrogen plants, they're typically, tens of megawatts, okay? So you need to have tens or 100 times more little plants, in this economy. Now, if you need to have a pool of engineers in every plant, and operators, that would be impractical, right? So really now with this economy, we're going for remote and autonomous operation with fleet management. So you have a fleet management center that monitors multiple little plants, maybe throughout India, managed from Bangalore, but it really could be across the globe, and managed from a single location, okay? Now, if you don't have the people in the plant, you really need to know well in advance if equipment are not performing or if there is a risk of failure, so that you can send people there. Because people are not there, they are autonomous, unmanned, okay? And you don't want to send their people on a periodic basis either, just in case. You want to send people there when you really need to. And that's, again, importance of having sensors and analytics in these plants, yeah? So, in conclusion, okay, with these solutions, plant get improved efficiency thanks to the performance monitoring. They reduce their losses and leaks, thanks to release failure detection and the energy balancing, mass balancing. You see energy conservation, because cost allocation and dynamic targeting drives more responsible behavior, and they see reduced carbon emissions, really thanks to all of the above. So, in summary, I spoke about three things. First, about why plants change. Well, because they want to meet their sustainability goals. Then I spoke about how plants change. Well, through new data-driven ways of working. And lastly, I spoke about what plants are changing. They are deploying additional automation, towards hyper-automation, if you will, with additional sensors and artificial intelligence analytics. Okay? So, well, here are my contact details. So scan this QR code if you want to connect with me. And well, I'm ready for any questions because I think we are at Q&A time.
Thank you, Jonas. Thank you for the wonderful session and a wonderful perspective also in sustainability. So overall, we had a diverse topic from machine to the data science to how it goes to sustainability, help the plant in improving their performance. Altogether, we traveled in this session is part manufacturing. We have a couple of questions also regarding that, but first of all, I would like to thank all of you for these wonderful perspectives all of you brought in, and it made this session very, very enriching. We have a couple of questions from the audience also. So if you allow me, then I can communicate.
Okay.
Yes. So the question to Dr. Jha is the facilities that have been shown here in your presentation are really, really impressive. How do you plan to train the say students as well as the teachers from outside so that they get more this kind of experiences and that can create more value out of it? So what is your take on it?
Yeah, so this facility, what I have shown is part of a common engineering facility center. It's not limited to IIT students only, because we have already conducted a good internship program to all students outside IIT itself. So there are more than 100 students completed their internship on this facility itself, working in the domain of smart manufacturing. We are also running our masterclass programs for every month. We are picking up one topic of related to smart manufacturing and training teachers basically and the students. So everything is available for access as it is, what we made available to IIT students. We will be running those training programs. You can join those training programs and your students can attend some of the internship programs that we will be announcing on this facility. So I think through that, the resources are available. Another important aspect, we are looking forward to extend the same in a hub and spoke model. So if your institute is willing to take this kind of an initiative, we are looking forward to just connect with you. Thank you so much.
Thank you, sir. The next question is to Dilip sir. So, sir, as you talked about the data part and how it can, the silos, the different silos, what is already existing, how it can blur the difference between the silos. So that part you were talked about. But what about the companies which are traditional industry? How is their willingness to deploy this kind of solution, or what is your experience on that? If you can share that?
Sure. So thanks, Utsav, for that question, because that's the reality, right? And you must understand that some people are ahead of the curve than the others, but a vast majority of industry, particularly in India, a lot of industry is MSME, right? Medium, small, and micro. So they're all starting from pretty much a similar place, right? I think it is not about flipping on a light switch and suddenly you are in a new state which is all digitized and with digital thread and all the other interesting things we've heard about today. I think it's about committing yourselves, reimagining a future where you're thinking of new possibilities, innovating around your business to drive better outcomes by utilizing these options, right? And you don't have to wait for big budgets to be approved. The first thing you need to have is intent and commitment, and then you begin to explore what are some of the areas where you can bring about improvement and start committing yourself to it, right? By taking some first initial steps forward, right? And I know that a whole lot of people are in that area. One thing which happened, and I think that's probably the only silver lining, that the pandemic left us with, is this strong acceleration that we saw. There's research that has now proven that we've seen the equivalent of about 7 years of acceleration in digital adoption in the industry in the last 18 months. So that's how much the whole thing has advanced. But I think the journey of 1,000 steps begins with the first step, right? Is for you to be able to start thinking about solving the challenges that you're experiencing by utilizing these new possibilities that are available to you right now. And that's where we are engaged. That's a part of the daily lives of the people who are on this panel today, right? And our organizations. So I would say that smaller organizations can make a beginning. You don't have to really have very big budgets. What you need to have is intent, curiosity, willingness to experiment, and support from the leadership to go out and try out new things, right? And once you take your first step forward, get some positive experiences, which gives you the confidence to go out and try new things.
If I may chime in, I agree with Dilip. First of all, you can't do everything in one go, right? It has to be a phased approach. Okay, and really the first step, when we have done this with many customers, and many of them in India, by the way, is that we start with a digitalization workshop, to find out what are the real problems in each plant of the enterprise, because not all plants are the same. They are different age and different industries, etc. So based on the outcome of that workshop, we then identify what are the digitalization solutions which are required. Okay, and we kind of prioritize them, so there might be a few related to energy and sustainability. It could be another few more maybe related to reliability and maintenance, maybe something to occupational safety and health, and something maybe a little bit towards production as well. Okay, and then we execute these projects in a in an agile approach, if you will, one by one, so that there is not too much sudden change, right? Because people can't absorb that much change, so by doing it phase by phase, it becomes a gradual transformation, which is easy for people to absorb, to incorporate into their daily work practices, without a whole bunch of disruption and conflict. Yeah?
Thank you for the diverse perspectives, and yeah, definitely. So, Jonas, with that, we'll come to you for the next question. When you showed that the preventive maintenances or the technologies what has been used for reducing, say, energy intensity, and where we are looking at a climate change kind of target, where sustainability is a buzzword right now, and every company is looking at the products, the supplier or customer, everyone is looking at how to reduce. So
Yeah.
my question is that this is one part of it, like the predictive maintenance part. But what do you see as a data utilization of digitalization and overall value chain? Like say, the virtual part, how can we more utilize that in this kind of scenario where not only the energy part we are looking at, but the product part also? How can we utilize that there?
What do you mean by the product part?
Yeah, so the product I mean, all the companies are trying to make it more less. The carbon footprint should be less. So one part is the product, like the energy intensity reduction in the
Yeah.
plants, but there are other aspects like the value chain where it is created.
Sure.
How data can be, enable us to reduce the footprint there? Is there?
Well,
Yeah.
yeah. Well, I mean, if you want to change, I mean, many people will change their process, right? They might use hydrogen. Chemical plants will use hydrogen, instead of LNG as feedstock in many cases. That like if you make like methanol or ammonia, for instance, they're going to use hydrogen as a feedstock. So that is a big change, which is great decarbonization, right? Well, to do that, you need more automation, to make that change, because yeah, you're going to need different automation to achieve that. So I don't know if that directly is anything with data. I mean, data is. Yes, I mean, that goes into the condition monitoring of the equipment, and the performance of the equipment, but a lot of that is more sustainability than decarbonization, I would say. Yeah, I mean, all the little brooks add up into a river, right? I mean, yeah, you can envision the Sankey diagram, right? You have seen all of those. So you really want to improve in all of these different places, and it all adds up.
Thank you so much. Thank you so much. I think we have 2 minutes left, but one more question, maybe we can take it up. One question is that, see, everybody is talking about more of automation, more of green, kind of thing, like sustainability and low carbon footprint, and this can reduce the human factor. Reduce the human factor. That's the general thinking. So I mean, all three of you, my question is that how this kind of thinking we can change, and what is the aspect you want to highlight in this kind of scenario when this kind of questions are coming?
Let me take a. Yeah, go on, Dr. Shah. Sorry.
No, sir, you go ahead.
Let's follow the question again.
Utsab, you're on mute.
So we are going on more of automation, more of less using automation or data to have a less human heavy enterprise, maybe where human interaction is less. So in that case, there's a thinking comes that humans are less and you are using robots. So there's a conflict somewhere is coming in. So how that kind of mindset we can change? I mean, it's a question to all three of you.
Yeah, let me take a first swing at it, and then Jonas, Dr. Jha, please chime in with your perspectives. I'll say this. Listen, Dr. Jha spoke about the aspirations that we have as a country to be a 5 trillion, GDP, 1 trillion manufacturing sector. There is just an enormous amount of new stuff that has to be done, which is multiples of what we are doing right now. We need people to be doing more, and we need more factories, to produce more cars and more food and all of that kind of stuff. So our productivity has to really go up. There's no other way to look at it. And we have to become much more efficient. So I don't think, it may be a poor unintended consequences. We end up eliminating a lot of jobs. But what we are trying to deal with is manage this, exploding levels of complexity that we encounter in manufacturing right now, which these technologies are enabling us to do, right? And yeah, it's making us more productive. So one person is able to do much more. And humans are getting equipped to tackle challenges which a person otherwise could not have. And you've seen several examples across the 3 presentations this afternoon, right? So I'll say that, the intent is not really to make human obsolete. The intent really is to augment the capabilities and get the human to do what they are best equipped to do, and equip them with the right insights and the right decision support at the right point in time so that they can take the best decisions at whichever levels. That would be my take.
Yeah, I mean, I remember one customer that we had where we did digitalization, and to this, he was speaking in a forum, and they asked him this question, and he said, "The plate is always full. There's always something to do in the plant, so essentially how many tasks you eliminate, well, there's always other things that you can improve, things that you never had a chance to work on before. Some tasks are automated, well, now you have time to work on those other things you never had a chance to work on before, and make all of these improvements that you want to do."
Absolutely. Yeah. Thank you. So thank you so much for this lively session with lots of new perspectives we